All right, 4.6 video notes, isosceles and equilateral triangles. So we discussed these triangles in 4.1 when we classified them, and now we're going to go into a little bit more deep detail where we're going to apply some of those properties and actually try to solve for some side lengths or for some angle measures. So just recall an isosceles triangle has two congruent sides. Don't really get caught up in the at least. Different textbooks, some say exactly two sides, some say at least two sides. Big idea that I need you to know is that it kind of looks like it resembles the letter A if you stand it up this way. So that's usually how it's drawn. The two congruent sides are called the legs. So you have a leg on both sides. The vertex angle is the angle that's formed by the legs. So this angle up here at the top, this one right there, that's called the vertex angle. So sometimes you may be doing a word problem that they just write it out in words and they don't give you the picture, and you'll have to kind of use that fact to know where the vertex angle is located. Now, the side opposite the vertex angle, down here at the bottom, this is called the base. All right, so this side down here, this is the base. So usually the base is on the bottom, but I could always tilt this thing sideways, which I'm going to do here in a second, and it's going to change position. But the base is always across from the vertex angle. And now these two angles down here are called base angles. All right, so you have the base, and then these guys right here are the base angles. So two base angles, one vertex angle, two legs, and a base. You know, in this triangle, you may come across a problem where it's drawn, you know, like this. And so now you can't always just say, oh, the base is at the bottom, because now the pieces are different. Now you have a leg, you have a leg, the legs are congruent. The base angles across from them are also congruent. So this would be a base angle, and this would be a base angle. And then your vertex angle would be up here to the top. Notice I put one arc on it because it's a different measurement than the base angles. And the base would actually be chilling over here on the left-hand side. So it all depends on how the triangle is oriented. The big feature, the most important feature, is the theorem right below that's called the Isosceles Triangle Theorem. And it basically says, and I'm going to scroll down in a second, but since we're looking at the picture, it says that if you know that these two legs are congruent, if you know the legs are congruent, then the angles across from them, aka the base angles, also must be congruent. So that's why I put two arcs there to show that they were equal. So anytime the legs are congruent, the angles opposite them are also congruent. So let's kind of go down. There's two parts to that theorem. So the Isosceles Triangle Theorem basically says if the two sides are congruent, then the angles are congruent. So if you know the sides, you get the angles. The converse, if you go back to chapter 2, if we switch if and then, it's also true. So meaning that if I know the two angles are equal, I then can say that these two sides are equal. And those might come up in a proof as we get towards the chapter test. So when we're doing our proof review, I will probably sneak an isosceles triangle or two into the question. And so that way you know that you got a pair of equal sides and a pair of equal angles. All right, well, let's use that information to try to solve some problems here. So example 1 says find the measure of angle F. So let's see what we have here. First of all, angle F is one of the base angles. So angle F and angle D need to be the exact same. The vertex angle is 22. So here's how I'm going to do this. I know that a triangle adds up to 180 degrees. So I do 180, subtract the 22, which would be 158. Now that 158 has to be split up between two different people. All right, because they're both identical. So I'm going to do 158 divided by 2, which comes out to be, what, 79 degrees. So I believe my answer to this first one is angle D or angle F are 79 degrees. I could always go back and double check and make sure that the three angles do add up to 180 degrees like they're supposed to. And let's see if they do. That's 20, carry the 2, 9, 16. Boom, so it checked out. All right, I made sure my base angles were the same. All right, next problem. Well, just looking at it, the first thing I need to find out is who's the vertex angle, who are the base angles. So since these are the two equal sides, the base is down here at the bottom. So this is the base, which means these are the base angles. They have to be equal to each other. So I can set up an algebra equation. Since angle G, okay, is congruent to angle J, you don't really need to write this part in there, but I just want to show you where it comes from. I know that x plus 44 has to equal 3x because those are the two in those positions. And I crank them out and I solve this equation. I'm going to minus an x from both sides. And I get 44 equals 2x, so x must be 22. So I solved for x. It didn't really say what I had to figure out. Let's just plug it in and make sure it works. So if I plug 22 in, that will give me 66, and 3 times 22 will give me another 66. So even though they didn't tell me what h, they don't give me an expression for h to plug it into, I can still calculate it, because 66 plus 66 is 132. And so if I do 132 and subtract that from how many degrees are in a triangle, it looks like 48 degrees. So I now have all three angles. I have the two base angles, and then over here I have the vertex angle. So I just wanted to do that example to point out that the vertex is not always at the top and the base angles are not always at the bottom. You have to look at how it's tilted. All right, example 3, the first thing I notice about example 3 is I have 3 markings. So this is not only isosceles, this joker is equilateral. And a corollary is all equilateral triangles also implies, okay, that they have equal angles, equiangular. And we learned earlier that equiangular triangles, equilaterals, are always 60, 60, 60. So if I need to figure out what x is, I know how much that angle is. 2x plus 32 is really 60 degrees. So let's find the x that makes that work. If I subtract 32 from both sides, I get 28. And if I divide both sides by 2, I get x equals 14. And if I plug it back in, 2 times 14 plus 32, it does check out to be 60 degrees. All right, let's crank up the heat a little bit, go to the next page, do a few more. So we have some problems that were stolen from another book here. You can kind of tell the format's a little goofy. ABD is isosceles. So ABD is this fat triangle over here on the bottom part. Okay, and that's isosceles. Well, who are the two sides that are equal? The vertex angle is ABD. So this right here is the vertex angle, which means the other two are the base angles. And so these are the legs that are congruent to each other. And now we should be able to hopefully get some work going here. ACD is a right triangle. So ACD is the big dog. The big dog is a right triangle, meaning that this angle right here is 90 degrees. So that's another clue. And they give me the measure of angle 6. They say the measure of angle 6 is 136 degrees. So let's just write that in here. The measure of angle 6 is 136 degrees. And they want to know what is the measure of angle 3. So I got some work to do on this one. So let me kind of start working through what I know. I know in this triangle, since these two angles are equal here, I'm going to do 180 subtract 36 and I get 144 degrees. And I need to divide that two different ways. That will tell me that these bottom two angles, whoa, 136, I almost screwed that up. So that would be 44 divided by 2, check that, which would be 22 degrees. So I know that you're 22 degrees and you are 22 degrees. So that should add up to 180. And now to get angle 3 that I'm looking for, it's a right angle, so it's 90 degrees minus the 22 that I have, and that leaves me with 68 degrees as my answer for angle measure 3. 68 and 22 would come out to be 90. And I could get everybody else if I wanted as well. Since I know that this one is 68, I could play the straight line game here, subtract from 180 and get a 44, and then 68 and 44, I could add those up and subtract from 180. So 68 and 44 is 112, subtract from 180, and that will give me a 68 up here. Wow, so it actually turned out that this triangle at the top, because I see these base angles are both 68, that triangle at the top is an isosceles. Kind of interesting. All right, example 5. If DE is congruent to CD, so DE congruent to CD, BC and AC, BC, AC. So I have two different isosceles triangles going on here. CDE is 120. Find BAC. Well, first of all, who the heck is BAC? BAC is this little angle right here. So that's what our ultimate goal is, find out how many degrees that angle is. So let's do some work. I'm going to start in the top triangle. They give me 120. So 180 minus 120 means there's 60 degrees left. And I got to split that 2 equal ways to get me 30 and 30. These two are the base angles that had to be equal to each other. I can now use vertical angles to jump in and get the 30. Now, 30 is not a base angle. 30 is the vertex angle. Okay, the base angles are both of these green ones down here. These guys are the base angles. They match up. So I got to play the same game again. I have 180 degrees in a triangle. I subtract the 30 in the vertex. Leaves me 150. Divide it by 2, which is going to put me at 75 and 75. So the answer to this question is 75 degrees. All right, I got 2 more to go. Scrolling on down. Looking good on time. Find the measure of angle X. Well, I see a couple clues in my picture. I have a isosceles there, and then I have an isosceles down here on the right, on the bottom. And then I see a little 90-degree mark, which is going to come into play. So if I need angle X, let's there's different ways to do this, but first thing I see is that these two angles here have to add up to 90 degrees. So if I do 90 minus 38, that's going to put this angle at 52. Now looking at this triangle kind of sideways, I'm only going to focus right now my eyes on this triangle because that's where the X is. I don't think I need the top triangle anymore. Focusing where my eyes are, if I notice since these are the legs, these are the base angles that must be equal, so this must also be 52. And now it should be pretty easy to find X. 52 and 52 is 104. Subtract from 180, and I find out that X is 76 degrees. Looks like kind of a similar game over here. I have an isosceles triangle. Base angle, base angle. Base angles are always equal. So that's 77 and 77. I add those together, which puts me at 154. So to figure out this vertex angle, I do 180, subtract 154, which is 26 degrees. Now using this 90-degree fact right here, I subtract 90 minus 26, and that's going to give me 64 right there. And now in this triangle to the right, so now I'm focusing, or the top I should say, I'm focusing in this top triangle. I have to identify who are the base angle and who's the vertex angles. Well, since this side equals this side, the angles across from it have to match up. So if this is 64, that one's 64. So the final answer is 64 degrees. So you can kind of see the same game played out over and over, but the key is understanding that in any isosceles triangle, the two sides that are congruent, the opposite angles, the base angles, are also congruent. All right, well, hopefully this will be enough to get you rolling tomorrow on the practice, and we will be wrapping up this chapter shortly. See ya!